Great. Okay, so good morning, everyone, from me. I'm Jeremy Cohn, Research Software Engineering Fellow at Imperial College London. And together with my colleague Steve Crouch, we're going to be running this second session in the Byte-Sized RSE pair of sessions that we're running for the Research Software Camp. So some of you may have been at the first session that we ran last week, which we looked at code review. And so if you were at the first session, you will recognize the format because it's going to be similar again this time. If you weren't, just to give you a quick overview of how things work, we will be starting off with a bit of introductory background material. I'll take you through a bunch of kind of different aspects of Git, which we class as intermediate or advanced features. And we will have a bit of an interactive part of that as well, where you'll get a chance to provide some input. And then I will hand over to Steve, who's going to run a sort of interactive session where you all can join in and choose to follow along if you'd like to, and try and do some of this stuff in practice. Okay, do feel free to put questions in the chat as we go along. We're happy to take questions, and there will be, I think we should have a reasonable amount of time at the end of the session for some discussion and questions and answers and so on. So, but we're certainly happy to take questions as we go along. This is really very much intended to be an interactive session. Okay, so what I'm going to go through is I'll just very quickly mention some prerequisites. Hopefully you've seen those before, but you probably should be in a position to have whatever's necessary on your machine to take part in the interactive part of the session anyway. But if not, I'll just give a very quick overview there, and then I'm going to look at some background to what we mean when we talk about more advanced Git skills. And moving beyond the basics, and look at the concept of branches, which some of you may have been familiar with in a basic sense, but we're going to look at that in a little more detail, and then look at this idea of feature branch workflow. And then we'll look at some features like rebasing, merging, cherry picking. Some of these might be things that you've heard of, but if you haven't, hopefully you will know what they mean after the session. And then we'll look at handling merge conflicts, which is something which can be a little bit of a challenge, but also a useful thing to understand, especially if you're working in a collaborative environment. And then it'll be time for the practical part of the session, where Steve will take you through an activity to look at some of this, where you can actually join in. Okay, so I mentioned prerequisites. Hopefully, since this is an intermediate Git session, most of you should already have Git on your system. If you haven't, then if you're running Windows, you can install via Git for Windows. It should be very quick to get installed. If you're on Mac or Linux, you probably have Git installed already. If you don't, on Linux, you can install it using whatever package manager you have on your system. And for Mac OS, there's some instructions that you can find. I think this was probably sent around in advance, so hopefully you've got the details with a link there. But any problems there, do post a message in the chat. And also, if you attended the last session last week, then we used GitHub for that. So you may have a GitHub account from that, or you may well have a GitHub account already. Again, if you're using Git already using Git at a some basic level, you probably got a GitHub account, either as a sort of institutional setup or something you set up yourself. But that's something that will be useful later on. Then you can go to github.com and sign up if you don't already have an account. Okay, so what do we mean when we say more advanced Git skills? So basic Git training generally focuses on a set of very sort of core concepts of Git. So this idea of adding files and committing changes, being able to look at your commit history to see what you've actually done in the past, and then checking out different commits, or in some cases going to as far as kind of reverting changes. So these are the sort of things that we see when we look at basic Git. And often the concept of branches and remotes and these kind of things is omitted from basic Git training, because it can get a little bit complicated. And especially if you're just starting out and Git is completely new to you, then there's quite a kind of a set of information to go through just at the basic level and to get your head around. So often these more advanced concepts are omitted. And if you want to work with Git effectively and you want to be able to collaborate with people, then it's really useful to understand this stuff. And that's the sort of thing we're going to go through today. And the other thing to highlight is probably that a lot of people learn this stuff on the job, as it were. So many of us are finding that if you know these things already, you've probably learned it by actually being in a team and having to participate in collaborative development work. And when you first started doing it, maybe somebody showed you how things work or what processes are used, and then you kind of worked it out as you go along. But it's certainly very useful. While there's no substitute for actually having a real project to work on, it's very useful to have some basic understanding of these things before you get into that situation. Or if you are already in that situation, hopefully this will give you some kind of more of a background or a sort of a base to work on with these skills to grow your skills further. So, as I say, most of the basic Git knowledge is something that you've probably seen this, the idea of adding files, committing files, whatever. And it's once you understand what you're doing, it's fairly straightforward. But Git is extremely powerful, and there are many complex features. And I think it's fair to say that even experienced users often find themselves learning different ways to do things. That there are many ways sometimes to solve a particular problem. And I think certainly from a personal perspective, I've got to the point where I've thought that I know all the things I need to know and everything makes sense, and then suddenly something comes up that you haven't quite expected, and you find that you're in a situation which you don't understand, and maybe you have to go and ask for some support from somebody who's got more experience than you to try and understand what's happened and to fix things and whatever. And so the more of a kind of general understanding that you have, the more you have the basic awareness of how Git works to underpin your knowledge, the easier it is to solve these kind of problems as you go forward. So we're going to look at this idea of a feature branch workflow, which is a kind of convention that's used in terms of how you manage Git projects in a collaborative environment. And there are many different options here, but this is one of the widely used approaches. And then we'll look at some of the other more intermediate and advanced features of Git. So what do we mean when we talk about the feature branch workflow? So if you're familiar with committing code to Git, so that process of writing something, writing a file, saying doing git add to add the file, to stage it for being committed, and then actually committing the file, and that kind of makes sense to you, then maybe you thought, okay, that's all fine, I'm committing stuff, but what is this? What are these branches that people talk about when they talk about Git? Maybe you've never quite understood what that means. So when you create a new Git repository and you start committing to it, all of the commits go into a branch effectively, but they go into a default branch, and that default branch is generally called main, or if you're working with older repositories or older Git versions, then sometimes it's called master. But this is a branch, but it's a default branch. And why is it called main or master? Well, it's a convention, and the default branch on a Git repository can actually be called anything. So if you chose to give it a completely different name, you could do. But for as I say, as a convention and for traditional reasons of how things are being designed in Git, there tends to be this concept of using master or main as the sort of default branch name. So that's fine. You've got this branch and it's called main, but in fact, always using that for your commits can be really impractical. If you're just working on your own, maybe you've done that and you've never really seen a problem with it. So you add some files in, you commit them, then maybe you go and make some changes, and you decide that you're going to add the changes and stage the changes and commit those, and you go on like this, and you've got a history of changes. And if you do a Git log, then you'll see this history, and you can see all the commits that you've made. And that's all okay, and it's in this single default branch, as we say, and we'll assume the default branch in this context is called main. So you've got this main branch, and all of your commits have gone in there, and it's great, and you don't see a problem with that. But then think about what happens if you're working with other people. So if you're collaborating with a group of people, maybe you make some changes to something and you want to commit those, but at the same time, your collaborator has also made some changes and they want to commit them. And suddenly there's a bit of a problem because you've both got conflicting changes. And trying to manage things like that when you've got lots of people gets really, really difficult. And if you did something like the carpentry's basic Git training, then you might have gone through the part in that training where you actually had the experience of creating a merge conflict and working with a partner on trying to actually solve that merge conflict and understanding how that works. And it's clear that that's a bit of a challenge. Now, you can't completely avoid these kind of challenges, because if you've got if you've got some changes, somebody else has got some changes, somewhere along the line, they need to somehow be merged together. But there are much more efficient ways to manage the process of making changes to the code when there's more than one person doing things. And in fact, even if you're working on your own, there are a number of cases where it's actually a lot more effective to use branches to manage your development processes. So we're going to look at how that works and what those are. So the key point here is that adding new code into a separate branch can be a lot more efficient. So how do you decide when you want to use a new branch? So as I said before, if you're just adding your files and committing everything into main, then you've got a whole bunch of different code changes that are all in one continuous history. And it's fine because you can go back and you can see what you did and what was changed at different points. But actually those changes might relate to a whole load of different things that you're working on. And perhaps you've got some different features that you're working on with your code. And some of them are kind of long-lived development projects. So you've got, say, 2 features that you're working on, and you've been doing it for each one of them for 6 months. And occasionally you go back and you make a bit of change to the code and whatever. And of course, if you're doing that and you're trying to commit those changes into main, but at the same time, you are making little sort of minor updates to your code to fix things or improve efficiency or whatever, and you're also committing those into main, it gets very confusing because you've got all these different sets of changes that relate to different things that are all in this one single history. So the point of using branches and having a feature branch workflow model is that you can collect a set of commits related to a given feature or to a given bug fix or to some specific change that you want to make in one space effectively, and you can kind of group together sets of changes for different things. And this allows you to make your changes more efficient, and it allows you to separate out different aspects of the code changes that you're making and more effectively manage the development process, and particularly the testing and review process. So really the key point here is that you're avoiding conflict with other changes during the development process. So if you think about it, you've got this main branch and you've got some code there that's at a given state and it runs, and you want to make some changes, and you've got 2 or 3 different features that you're working on, which are going to take you a bit of time, but you also want to be able to just make minor changes. You've spotted a typo, or you want to add something to the documentation or whatever. And if you create a branch for each of these different sort of little sub-projects, as it were, then you can effectively manage your code in those separate branches for those different features. So I'm going to add 2 features to my code. So I create 2 different feature branches, called feature branch 1 and feature branch 2. And I can go off and change between those branches as I want to, and make changes to the code that relate to the feature that I'm looking at. And what I then have is a collection of changes in feature branch 1 that relate to only that particular feature that I'm developing, and then a set of changes in feature branch 2 that relate only to the set of changes for that feature. And what I can then do is much more effectively manage the process. So there's a question in the chat there about what's meant by a feature. So that's a good question. I'm sorry that I wasn't clear about that. So when I talk about feature, basically talking about something that you're going to change in your code, or some change that you want to make to your code. So let's say for argument's sake, you've got a piece of code that you've got a user interface that perhaps I'm trying to think what's a good example for this. Basically, if you've got a task that you want to achieve with changing your code, that would be a feature. So if you've got a user interface and you want to add a new button to your user interface, that might be a new feature that you want to put in. So somebody's decided that it'd be useful to have a new button that you click and it pops up a form for somebody to enter some details. So maybe they want to add their name onto the user interface or whatever. It's a very, very simplistic example, but that would be classed as a feature. So you would document what you want to do there. You'd say, the change we want to make is add a button, and when the button is clicked, a form pops up and somebody can enter some text, and then they're going to save the text. And that would be then classed as one feature change that you're going to make. And then you can collect all of the changes to the code that relate to that particular update in one place. And maybe at the same time, you've also got something where you've got a kind of underlying algorithm that runs behind your user interface that's doing some particular scientific process. And you want to make a change to the algorithm itself because you've spotted that you could make it more efficient by changing something. So that is kind of completely separate to something where you want to add a button to the interface and have a form pop up. It's a very kind of, it's another area of the code. So you would create a separate branch for that, and you'd call that another feature. So it's something else that you want to change. if we were looking at this in the context of developing something where you've got a sort of a team of developers working on a project, and you've got perhaps a client or somebody who's giving you a spec of what they want you to build, then in that context, the features would basically be all of the things that the client is looking for in the code, all of the particular pieces of functionality that are being looked for, and you could then have all of those as separate features. So yeah, so there's a point there that Matt's put a nice explanation in the chat. So thank you, Matt, for that. But yeah, it's a unique piece of functionality is probably a very nice way to structure it. But thank you. So thank you for that. So when we talk about this concept of having a separate branch per feature, it's very much, I think, it's down to you as the developer to decide the kind of granularity of the changes that you're going to make and how you want to represent those in the context of features. But so it's very much a kind of, I guess, a developer specific thing to decide sort of how much of a particular change or a particular piece of functionality you class as one feature. So, you know, maybe if you've got a very large change that you're going to make to the code, so you're going to add a lot of new functionality, it may be that functionality represents one particular item of material that you want to change in the code. But actually, if it gets too big, then making really big changes can be difficult. So you might want to break it down into a set of separate parts and then have those as sort of separate features that you work on. But this is really down to you as a developer to decide how you want to structure that. Okay, so the main point here is that the concept of the feature branch workflow is this idea that you have a set of separate features, and for each one you create another branch, and you can work independently on those features. And then at some point, at the end of the process of working on the features, you need to bring everything back together. So if you've implemented 2 different new features in your code and you want to make those part of the main code, so you've got this main branch where your main code is, and we'll look at some little diagrams in a minute, which hopefully make it a bit clearer for you. Then you would need to merge your changes all back into the main branch. And that's when it gets interesting, because you can have conflicts and you might need to address them. And we'll look in a minute at how that works. But the main takeaway from this is this concept of the feature branch workflow, which is that each feature is implemented in a separate branch, and you have a workflow and process where you create new branches as necessary, and then you have a process for merging them back into the main code. Okay, so we'll take a short interlude here and go and do a little interactive part of the session. So if you go to your web browser and you go to www.menti.com and you put in the code that's there, 39811582, this will hopefully bring you to our Mentimeter slides. I will move across to the slides now, but that code will remain at the top of the screen, and you'll be able to see that if you haven't got there yet. So I can see people are already finding their way there. So I'll just give you a minute to join up. So, and you can see the code there at the top, 39811582. Okay, so I'll just give it another few seconds for people to join. Okay. So I'll move on, but you'll be able to catch up. You can join at any time. So, right. So if you joined us last time, this will again be something that's familiar to you, our little kind of note at the start. So I think the point here is to say that we're going to ask you some questions about kind of what you do or your practices with these things. And it really is, the responses are all anonymous, but it's useful if you answer truthfully, both for you and for the other participants, because it will give people an idea of kind of what everybody's doing with things. And the point you are not alone is definitely, I think, an important one, because we all find that we probably do things that perhaps aren't always best practices that we follow, and we are certainly definitely not alone with these things, I'm sure. So okay, right, so first question is just for us to understand a little bit more about why people are joining the session. So what is your main reason for joining the session? So I'll just give you a minute to put in answers there. So there's one that's you have basic knowledge of Git, but you find it confusing, and I can see that that's a lot of people who are in that position. Some people who've already got advanced knowledge of Git and would like to refresh their knowledge. So quite a few people here. Also nice to see there's a few people who want to teach colleagues or team members about using Git, and so this is a useful option. We've got one person there who's joined for another reason. So if you have joined for another reason and you'd like to tell us, you're very welcome to put it in the chat. And likewise, also nice to see that we've got certainly at least one person who's also doing training and wants to see how the sessions work. And I think on that point, I should just note that yeah, this model for the sessions is something that we've been trying out with, I think, quite good success. More generally, we've done a session, we've done a series, sorry, of bite-sized RSE sessions independently of this research software camp, which there's details online, and we've done 8 sessions in total, so you can go back and have a look at those if you haven't already seen them. But we can certainly provide details of that if that's of interest to you, and certainly happy to support people who want to run kind of similar sessions. Okay, so as we probably expect, I think the vast majority of people are people who've got, in fact, not the vast majority, but the majority of people are people who have basic knowledge of Git, but find it confusing. And then we've got quite a number of people who are just wanting to refresh their knowledge, and a few other reasons as well. So thank you for your answers there. I will move on. Okay, so how long have you been using Git? So less than 6 months, 6 months to 1 year, 1 to 2 years, 2 to 5 years, or more than 5 years. Or maybe you don't use Git at all and you've just kind of joined to see what's going on and how the sessions work and what we're covering. And if you don't use Git, then I don't know, maybe you are completely new to version control, in which case we can certainly point you in the direction of some really good introductory material. But equally, if you are using another version control system, there are many others out there, so you're using something else. Yeah. Okay, so actually some really quite experienced Git users here, so that's good to see. So we've got a really nice kind of split of almost certainly at the from 1 to more than 5 years, a sort of even split there of responses. So really nice to see that we've got people at all different levels here. So I'll just give you another few seconds in case somebody else is still responding there, but I think that's probably everybody. Okay, so that's great. We'll move on to the next one. Okay, so how did you originally learn Git? So this is always interesting for us to know, because it's good to get an idea of where people are getting their kind of technical expertise from and how we can support that. So through a carpentries course is the first one. So that would be through the sort of software carpentry, or one of the other carpentries courses that runs where they include Git, through another training course, or through on-the-job training, or informal support from colleagues, or you taught yourself. And very interesting to see actually here that the largest responses there are people who taught themselves or had informal support from colleagues, and that's, I think, a really interesting result, because I think I possibly would have assumed that more people had been trained through either carpentries or through another training course. So that's really interesting to see, and it's great that people are teaching themselves. And I think I guess in this community we often have to teach ourselves new techniques and new tools and whatever. So that's perhaps from that perspective not so surprising, but yeah, I think it's something where there's perhaps not enough support for learning these kind of things as there could be. So that's a very interesting response. Thank you everybody for that. Right, so we'll move on to the next one. Okay, so this is where we start to look at some of the features. So have you heard of any of the following features? So branching, merging, tags, you should be able to pick multiple responses, I should say, rebasing, cherry picking, resetting, or bisecting. So, okay, so actually people have heard of a lot of these features. I'll give you a minute to... So only a couple of people who admit to knowing about Git bisect, but I guess, as we might expect, a lot of people have heard of branching and merging, and in fact, quite a lot of people have heard of rebasing as well, but less so for some of the other options. So another 10 seconds if you're still submitting, and then we'll move on. Okay, so I think we've probably got all the responses in there. Okay. Yeah, so just say this is about whether you've heard of something, not whether you understand it. So we will hopefully after the session you might have more of an understanding of it. But yeah, this is more about whether you've heard of something rather than whether you actually understand what it means. Okay. Right, so I'm going to move on now. So thank you for all the responses there. Okay, so this is where you get a chance to provide some more open-ended responses. So tell us about things that you find challenging or confusing in Git. So this is where we're kind of keen to just get some thoughts from you on what are the particular things that you are keen to understand more about, or that you find more difficult. And I think this is probably useful for everybody to see what other people are finding is challenging. So I'll give it a minute for you to think what to write and to put something in, and we'll hopefully see some answers coming up. Here we go. Okay. So yeah, so that's more of a some more advanced, really much more advanced things coming up here. So authentication for remotes, yeah, that's something which can be a challenge. Git conflicts, yes, that's I think something which and there's another one there. There's a lot of things here about conflicts, merge conflicts, dealing with merge conflicts. So that's something which we will look at shortly, and Steve will be looking at that in the context of the interactive session as well. Yes, so there's a really good point there about getting the basics, but then being lost when it goes beyond that. And I think that's a really big problem that so many people have with Git. So there's a point there also about Git stash and head. These are all things which are sort of terminology that you get in Git, which are really quite confusing if you're not familiar with how Git works underneath. So more there about conflicts, some really, really useful answers here. Yeah, large files and forks and branches, that's also an interesting one. Large files can be a challenge with Git. Rebasing, other sorts of conflicts, yep. Yeah, so there's a lot of things here, I think, with Git. That's a good point there about doing stuff kind of automatically when it's basic, and then but still, knowing that there's more advanced things that you want to learn. I think that's something that we tend to find with these things. Once you have to do a lot of work with coding and storing stuff into Git, then you get used to doing the basic stuff, but it's very easy to kind of forget about the more complicated stuff and try to manage with what you know. And I think we probably all do that to some extent. But it's, again, it can always be useful to understand, even if you don't use the more advanced features, what they mean, because that can help you with more of an understanding of how everything works. So yeah, that's really good. Yeah, so actually there's a point about how often should I commit. That's probably something which is, again, there's no rules as such for these things, but the answer is, I suppose, that you should commit effectively each time you make a kind of appreciable change to the code. So you don't want to commit every time you change a couple of it depends what you're doing, of course. If you're making a very, very small change, such as there's a typo in some documentation, you might fix the typo and then make a commit to say that you fixed it. But if you're working on actually a large chunk of code, there are some people who commit every time they sort of change a line of code or whatever. That gets very difficult to manage if you don't squash your commits, which is something that somebody else has mentioned there on the side. So when you squash commits, you take a whole set of commits and you effectively just crush them down into one single commit. And the benefit of that is that if you've got a very, very long history of little changes that all relate to one thing, if you squash everything down, you lose all of the sort of unnecessary multiple commits if you've got a particular feature that you've put into lots of separate commits. But of course, if you do that, you lose the history of what happened in between if you squash things. So how often you should commit is really down to, I think, making a decision about the kind of granularity of how much you want things to be represented within your repository. And if you change stuff, if you commit too often, then it can get a little difficult to manage because you've got such large numbers of commits. But if you don't commit often enough, then you find that you've got changes that are too big. And that gets very difficult to manage if you need to revert something, or if you need to sort of undo something that you've done and go back a bit. So there's no simple answer, but I think so that there are some general kind of guidelines. I think, Steve, maybe you mentioned something in previous session about Git that we did, about some guidelines on how frequently people should commit. Maybe that's something you can either come to now or maybe mention later in the interactive session. But yeah, it's definitely a difficult one. And yeah, there's another point there about how often to commit in the initial stages of development, which I guess is the same thing. So obviously, you know, if you're starting to build something from scratch, then you tend to be writing quite a lot of code. And again, I mean, generally, you would probably want to be committing stuff. I would say per sort of, you want to break your features down into a very small set of key things that you're changing as you go along, and you probably want to commit often enough that you're bundling up a bunch of stuff that means something in the code. If you just make a change every time you write a line of code, sorry, if you make a commit every time you write a line of code, that has very limited benefits. But if you know that you've done something that relates to a particular piece of functionality, then it's useful to commit that, so that if you ever want to undo that and you make other changes or whatever, then you can do that more easily. So okay. Anything else though? I guess probably, so there's a point there about what to do if you make a mistake. I mean, that's always a challenge, and we've probably all been there and done stuff where we realize we've messed something up, and especially if it's a big collaborative project, that can be really quite nasty. But normally the other people on the project who are more experienced with the project structure in Git will be able to help, and they've also probably been there themselves as well, because it's only too easy to make a mistake of these things. And there's things there about force, rebasing, complex conflicts. Yeah, this is all really quite. I think there's all difficult things. There's no easy answers to these things, but really useful set of feedback. So thank you everybody for that. Some really good responses there. Okay, there's a question about how the recording can be accessed, and I think that it's going to be made available on the SSI YouTube channel. There'll be details of that, I think, sent out by Dennis. Or a member of the SSI team, maybe Gina or Dennis will send something out about that after the session. But yes, it will be available. And yes, the slides, I'll also share a link to the slides for you. Okay, right. So so with that, that brings us to the end of the Mentimeter section. So thank you for all your feedback there. That's really useful. I'm going to switch back now to the slides, and we're going to go and look at some more diagrams to hopefully give you a bit more of an understanding of how everything sort of works in Git. Okay, so we're going to come and look at now this idea of merging and what the different options are with merging. So why do you need to merge? Well, if you're using an approach where you use branches, then you've got your main branch, your default branch. You branch off of that and you do something where you make some changes. But at some point later, you need to make those changes come back into the main code, into the main branch of the code, and that's called a merge. And what you're doing is taking the stuff that's in your branch that you've created, and you are, as the term suggests, merging it into the main branch. Now, if nothing has changed in the main branch, perhaps because it's something where you're working on a project completely on your own, and you've branched to do a particular feature in your separate branch, you've implemented that feature, but you haven't done anything else to the code, then merging is really simple, because actually nothing has changed in the main branch since you branched off it. And all you do is you just take your changes and you just move them straight into main. It's all exactly the same. And it's a very simple process. And we'll look at it in a moment, as I say, at some diagrams that show this. But actually, if you have made some other changes to main, or you've made changes to other branches, then you start getting into a more complicated situation where you need to try and work out how to make the changes all kind of fit in together. And if you change completely different parts of the code in your multiple changes, then it becomes much easier to deal with, because a merge can check whether there's lines that are actually unchanged in the different pieces that you want to merge, and it will make sure that everything gets kind of interleaved together. But if you've got the same line changed in two different sets of code, then it gets really difficult, because actually Git is clever up to a point. But if you've got a particular line of code which is different in two versions of things that you want to merge together, it doesn't know what to do with that. And it's down to you to decide what you want to do. And then you get into the point where you have a merge conflict, and you have to manage the process yourself, and you have to decide what you want the code to look like at the end. So that can be a little bit more difficult. So there are two different, there are some different approaches to merging. And if you do a regular merge, then you'll get something which is called a merge commit, and we'll see in a minute how that's represented. And this is a process whereby you're taking stuff from you've got one branch and you've got another branch with some changes in it. You want to merge them together, and as we'll see in a minute, a merge commit, it goes through this process of a three-way merge, and you end up with an additional commit that's been put in by Git that represents the fact that you've done a merge. Now, some people are quite happy with that approach, and it's fine, but there's also some issues with that. The alternative option, which people use because they want to maintain a continuous commit history without merge commits, is to do a rebase and merge. And we'll see again, as I say in a minute, we're going to come to the diagrams, which will make this easier to understand. But if you do a rebase and merge, then the way that this works is that if you've got a main branch, so got a main branch with some commits on it, you branch off of that to go and do some other work, and then later on you want to bring that work back into the main branch. If you are going to make that change and do a rebase, then I'm actually not going to try and explain this without showing you the diagram. So I'm going to move on and show you the diagrams to explain that. But it's important to understand the nuances of committing code, and this is especially the case when you're working in collaboratively. So as I say, let's look at this in a diagrammatic form because it's much easier to explain. So here's an example of a very simple repository and a set of changes that we make. So we start off here with this initial commit. I hope you can see my mouse pointer on the screen there. I presume it's showing up. So you start off with this initial commit and you make some changes to it. So the initial commit is some basic bit of code that you put in, or in fact, it could be just an empty, a README file or something you put in at the start, just a first commit to your repository. Then you do some work and you implement something and you commit it. So that's your commit B here. So you've written some code and you've committed it. So assuming that our default branch is called main, we have a kind of pointer effectively here that points to the current most recent commit. So the main pointer is pointing to our commit B there with the changes that we've made. So now we've got something which we've decided we want to add a particular new feature to it. And so what we're going to do is, rather than just committing more things onto main and adding another commit up here and moving the main pointer up here and moving right up, we're going to create a branch. And we can represent this as showing that something sort of goes off to the side of the main branch. So at this point, we're going to create a branch called feature/test. Again, these are conventions you can call. So some people name feature branches feature/ and then the name of the branch. You can call it absolutely anything. It doesn't have to have feature in there. There doesn't have to be a slash, whatever. This is just a naming convention. But what we've done is we've created a new branch. And when we create a new branch, we effectively move off to the side here. So the main branch, the main pointer, is still pointing to this commit B. And then we created a new pointer called feature test. And initially, when we create the branch, feature test is at the same point. It's here when we create the branch because there's nothing else in the repository. There's just these two sets of these two commits. But when we then create a new thing, so we do commit C, so we change something for our new feature, we commit it. Feature test now moves up to here. So feature test is pointing to this commit C. Then we make another change. So this is all part of this new feature that we're implementing. So we've added some more code and we commit that, and that's commit D. And then our feature test pointer is pointing up here. But note that all the time, the main pointer is still pointing at commit B. So if you check out your main branch, so for those of you that are familiar with the git checkout command, if you say git checkout main, then you will see only these two commits, and the code, as far as Git is concerned, this is all that exists when you're in main. But if you were to then go git checkout feature test, then you will see all of the code through all of the commits up to this point here. So at the moment, we've got these two commits here, we've branched off and we've got two more commits. Now, at this point, if we want to merge our changes here, C and D, back into the main branch, it's actually really simple because, as you can see, main is here. There's no other changes anywhere going off in other directions. All that's happened is there's two more commits here. So what we can effectively do is just take the main pointer and move it up to commit D. So main no longer points to commit B. So when we do a merge of feature test into main is how we would describe it. So we're merging feature test into main. What we're actually doing is just taking the main pointer and moving it up here and having it point to commit D. And you can see that represented here. So what we've effectively done is taken the two commits that branched off and moved them into the main branch and moved the pointer for main to the top. And the reason we could do that is because actually nothing else changed from commit B. That the history is continuous. There's been 2 more changes on top of commit B, but nothing else anywhere else has affected that. So that's what's then called a fast forward. So sometimes if you do a commit, you'll see it says, if you do a merge, you'll see that it says fast forward. And basically all it's doing is taking main and forwarding up to the top here. And it doesn't actually have to do any sort of merging or anything because there's nothing else to change. Okay, so that's the simplest form of merging. Where it gets a little bit more interesting is if you have conflicting changes. So if you think about our thing we had here, so what we've done is we had our 2 commits to start off with where main was. We branched off and we created commit C and commit D. And there's our feature test branch, which is pointing here. Now, while we were doing that, we also decided there was another feature that we wanted to add. And so we branched off from main again. And this time we called it feature test 2, not most inventive branch name, but there's our second feature branch. And we then, so we started at main, we said git checkout -b, so that if you want to create a new branch, you can check out -b to create the branch. And then in this case, feature test 2. And that created as a new branch, feature test 2. So that starts off at this point because there's no other change. So it's feature test 2 is there. Then, as you can see here, we added another commit. So we did some work on this other feature and we added another commit, and that's become commit E. So feature test 2 is now pointing to commit E over here, and feature test is pointing to our commit D over here. So basically our main branch has diverged into down 2 different routes. And we've got one set of changes relating to one feature here and one or more commits here, because this could obviously proceed up this line, relating to our second feature here. And at some point, what we're going to want to do is to put all of these together into our main branch, assuming that we're happy with all of them and they're tested and they're all working. We want to move them back into main. And so the way that we could do that is we're going to have to do some merging, clearly, because we're going to want to merge feature test 2 into main, and we're also going to want to merge feature test into main. So how might we do that? Well, let's say we decide, so the first thing to note is that whether we merge feature test 2 or feature test into main, the first time we do that, it's effectively just going to fast forward, because main will either move up to here or main will move up to here. So what we've decided to do is we've decided to merge feature test 2 first. So we merged feature test 2 into main. And what's then happened is we now get something that looks like this, where we have initial commit, commit B, commit E. And then the main pointer has moved from here up to here. And I've represented the merge by just moving it all into a straight line. But actually all that's happening is a pointer is changing from one commit number to a different commit number. So that's this bit that we have now. So this is now okay. That was a pretty straightforward thing because there was no other conflicting changes. But now we have a problem because we have our feature test branch coming off of commit B and going up here. And we want to get this stuff back into the main branch. But of course, this stuff here now has a divergent set of changes. So we can't just do a fast forward, because if we just move the main pointer across to feature test, across to commit D, then we lose the stuff here in commit E, because we're basically then going off down this route here. So we can't do that. So we need some way of kind of combining these changes together. And that's when we get this point of whether we do a merge commit or a rebase. And I'm going to show you what those two look like. So if we do it as a merge commit, then what we get is, oh, sorry, go back to that. Right. So if we do this as a merge commit, then here's our state where we were on the previous slide. So we've done our merge of commit E. So we've merged feature test 2 into main, and that's nice and straightforward. But what we're now going to do is say git merge feature test into main. So git merge feature test main. And what then happens is that Git then creates what it calls a merge commit. And a merge commit is effectively something which says that 2 divergent sets of stuff have been merged together. So what you get is something that looks a little bit like this setup here. So what we've done is we've created a new commit here. We've taken the code from the changes in C and D, and we've merged it in with the changes from E. And we've then got this thing here which says that it's got effectively it's a parent of 2 different child commits, E and D. And you can see that that's represented. If you do a git log, when you've done a merge commit, you will see that there is a new commit created and it says merge, and it tells you the the two commits that this has kind of brought together effectively. And so what you can then see is that you had commit E, which has this particular commit hash, and commit D, which has this commit hash, and that's what's represented in the merge commit. Now, the way that actually looks when you look at a Git log, you don't see it quite like that. You actually see something which looks more like this continuous history of commits, but there is a merge commit there, and that merge commit will tell you that it's a result of merging two divergent sets. So there's a question there, why is E after C and D? So yeah, that's down to how it merges, and I think it's to do with how the three-way merging process works. But ultimately, it could, I think, appear the other way. So yes, it would be more logical, you would say, that because we merged E in first, it should be B, E, and then C and D. But in fact, if you actually look, I mean, in the case when I did this, it actually came out that way round. So that's, but the point there is that when you look at the merge commit, it will tell you what the two things were that it came from. Now, why people often don't like this is because this gets really, really complicated to work out. When you look at a commit history, and you've got a bunch of merge commits in there, you get something which looks like this history, and exactly as you just pointed out, you can't really tell, although the commits are all timed, so you could probably work it out. If you get a very big repository with lots of commits, it gets really difficult to actually understand the history. And I think they may, as I said there, they may just be shown chronologically by commit time. That may indeed be the case. So you might actually find they're interleaved if they were all committed at different times within the different branches. I think that may well be the answer, as was just noted in the chat there. But the point is, it's just difficult to work out what's happened. So if you want to follow back and work out exactly what order things were done, how they were done, it gets a little bit messy. Because what then happens is when you put another commit on the top, so you now add something else into main, and you commit that, you've then got the next thing that appears above the merge commit, and you carry on like that. Okay, so what's the alternative to doing a merge commit? The alternative is to do a rebase. And the reason why people like rebase, or often like rebase, is because it gives you a way to have a more consistent Git history without merge commits, which is easier to follow, and it's easier to try to track back how changes have worked. And how does this work? Well, if we go back again to where we were 2 slides ago, we were at this point where we had a bunch of change. We had our main pointer here. We'd then done two sets of changes in 2 feature branches. So we created our feature test branch, and we made our commits C and D in there, and then we made our feature test 2 branch for our second feature, and we had commit E there, and we then did our merge of feature test 2 into main, and that was nice and easy, and it fast forwarded the main pointer to commit E. And then we had this divergence of the two the 2 commits that were in feature test. And so when we looked at merge commit, we ended up putting another commit at the top, obviously, and showing that that was a parent of two other commits. But the alternative is to do rebase. And when you do rebase, what you basically do is you take these 2 commits here, you take them away. So they were originally commits that came off of commit B. So commit B was the next commit back in the history from here. What you do is you remove these 2 commits. So you take the content that's in them, you put them aside, and then you take them and you put them on top of the current main pointer. So the way that works is basically shown here. We're kind of taking those aside. So bear in mind, these commits are literally just a set of changes. They're just represented by a group of changes to some previous point in time. So what you can do is take those 2 change sets. So this is just 2. If you're familiar with diff, then it's basically 2 diffs. It's 2 changes to code. So commit B, we have the code at a particular state, and then these 2 commits here, C and D, are just 2 sets of changes that have been added from B to get you to this point. So what you do is you take those 2 sets of changes off, and then you replay them on top of commit E. So the changes that are represented there get reapplied on top of commit E, and then the changes represented here get reapplied on top of that one. And what you then get is something which looks like this. And what's the benefit of that? Then you find that you've got a case where you've now got a continuous Git history without a merge commit. So there's a really good question there. With rebase, what would happen if the same bit of code was modified within both commit E and commit D? And yeah, if that happens, then you're going to get a conflict and you have to address the conflict. But in doing that, you then get an additional commit that will change that will represent the changes. So sorry, I'm just checking the questions here in the chat. So so there's a question here: if using rebase makes it easier to follow the history, is there a disadvantage to using it? So that's a good question. I think there are different reasonings behind why people prefer one or other approach. And I mean, one of them is that if you're kind of grouping features together, then one of the benefits, I suppose, of having merge commits is you can see that there's been, a set of changes merged at different times. But I don't know whether, Steve, maybe you've got some from working on sort of projects where these different approaches have been used. You might have some thoughts on that. There's another question there. Why is main pointing to commit E? Shouldn't it be pointing to commit D? Right. So okay. So what's happened here is, yes, I think so. What I think's happened here, this might be me getting with my thinking. That's a very, very good question. I think that this is again because it's just displaying the log in chronological order, as was suggested before. So actually, the change sets, but you are correct. I think it should probably look like it's got C and D once they've been replayed should get retimed. That's something we can check and see. But the principle is that you're effectively adding these things on the top, and then you're avoiding this need to have a merge commit. Okay, so it's a little bit complicated to explain. I hope the diagrams have given you some sort of example of what's going on. Okay, so yeah, there's some really, really good feedback from in the chat there from Matt. So thank you for that, Matt, about sort of different approaches that people use. And I think this is something where, again, there's no right way, as it were, for this. I think many different teams use different approaches, and both in the research community and in industry, there are different kind of conventions that individual teams use for different reasons, and those might be historic, and they might be to do with something that fits better with the particular approach that's used locally. But ultimately, there isn't a right or wrong way, but it's down to what's preferred and what works better for you, or what you think is better in the context of the project that you're working on. Okay, so in view of time, because I know Steve wants to get going with the interactive session, I'll just finish off with some other thoughts, and these will come up again in the later bits when Steve goes through some stuff. So hopefully that will be. But I'll just sort of cover a couple of points here. And of course, this is something we should say. But we're fitting this. I mean, part of the bite-sized idea is that it is sort of short sessions, and we're trying to fit a huge amount of stuff here into a very small amount of time. And there's obviously this is something we could probably do, sort of 1, 2, 3 day course on going through this stuff in great detail. So I appreciate that it's a quick run through, but I hope it's giving you at least some idea of what these different terms mean. So some other features that things you might have heard of or that you might come across. So Git cherry pick is something which lets you take an individual commit from another branch. So as I mentioned before, a commit is just a set of changes that are represented at that point. And so if you use cherry pick, what you can do is just take a commit from another branch or from another location, just using its commit ID. So every commit has a unique ID. And you can see that when you do git log, you'll see the ID of the commit. And you can say git cherry pick and then the ID, and that will take that commit and put it onto whichever branch you're currently in. So if you're currently on your main branch, it will take it from wherever it is and add it onto the main branch. And the reason you might use that is if you've done a bunch of commits in a branch, and those commits represent different parts of say a feature that you've added or something, and you find that the rest of the stuff isn't any use, but actually the one change that you've made, or maybe it is useful, but you've used it in a different part of your code base. But one of the changes that you've made there is something that's really, really useful, and you don't want to have to implement it again separately. So what you can do is just cherry pick that commit into another location, and that will enable you to take that set of changes and use them somewhere else. The other thing is stashing changes. Somebody mentioned that before. So there is this concept in Git of a stash. It's basically a kind of local store of some uncommitted changes. So when you want to check out some updates, so often if you want to git pull, and you've got local changes, it either won't let you pull because it will affect the local code, or depending if you've committed changes, it's a little bit different because it will try and do a merge. But if you have changes that are uncommitted locally, so you've changed some code, you haven't committed it, and then you want to pull some updates from the remote, then you'll get into a problem where it won't let you pull because there might be conflicts in the change. So what you can then do is git stash, and that will take all of the changes that are made locally, just the diff of the changes from the latest commit to the things you've edited locally, and put them in this kind of local store. And it holds them there, and then you can, and it basically undoes the changes to the current state of the code base. So then you can pull changes from a remote, for example, and you'll get a fast forward or whatever to move you to the next stage of what you've pulled from the remote. And then you can pop the changes from the stash. So the stash is a bit like a stack. So if you've got familiar with the stack in some computer science terms, you've got a set of things that pile up, and it's a kind of last in, first out queue effectively. So the last thing that got put on the stack is the first thing that then comes off. So you pile up these things, and then you can take them off one at a time. So if you have a stash, you can git stash something. If you have some changes in the stash, you can then pop them later and say git stash pop, and it will take the last group of changes off the stash and put them and apply them onto the current set of code. And that's useful if, as I say, if you want to pull an update from remotely, then you can stash your local changes, pull the update from remotely, and then pop the stash. And of course, if there's changes between what was pulled and what's in the stash, then you'll have to do some work there'll be a conflict, and you'll have to do some work to integrate the changes if there are common lines that are changed. The other thing that's useful to know about is git reset. So that lets you undo commits locally, and it will convert locally committed changes to uncommitted. So if you reset, if you've got some commits that you've made locally, you haven't pushed them to a remote, and then you've decided that actually you don't want to have that last commit because you made a mistake and you want to change something. Rather than adding another commit with the change, you can git reset, and you can either git reset to a particular commit using its ID, or you can take the head, which is the term that references always the current kind of top of the line of commits that you're on. So the head will always be the latest commit on the current branch that you're on. And what you can do is you can say git reset head, and then you can use tilde. So you can say git reset head -1 will be effectively head -1. So that will take you back one commit, or head -2 will take you back 2 commits. So you can kind of rewind effectively your commits to a point where you then have just uncommitted local changes again. These are all things we can demo if people are really keen to see these things. But I think it's really just, again, it'd be useful to have some diagrams to show that. But in the time that we have available, we can't go into that in great detail, but it's really to highlight that's available, and that you can do that. And there's lots of documentation for these things out there that you can go and look at. Okay, so as I say, with that, I know that time is of the essence, so I'm going to hand over to Steve, and he's going to take you through some of the practical side of the session, and there will be time, I'm sure, to look at some of these things later on, and I will try and address questions that are in the chat there as well while Steve is going through things. So thank you everybody for all the questions. Thank you for sharing your thoughts with the Mentimeter part of the session, and I will hand over to Steve. So I'm going to unshare my screen.
Thanks, Jeremy. Okay, so some very interesting points brought up there. I hope to address probably at least half of them, I think, as we go through the activity. And the advantage there is I think we'll be looking at some of those points that have been brought up in context as we're going through the activity, which should be helpful. Hopefully. Right, so what I'm going to do is I'm going to share my screen. So if my client will allow me to do that. There we go. Right, okay, so is that looking clear? Yeah, okay, thanks. Right, okay, so let's have a talk about what we're going to do in this activity. Right, so I just need to move some of my windows around. There we go. Right, okay, so what we're going to cover today. So we're going to, firstly, what we're going to do, so introduction. So Yes, in this activity, we're going to take a practical look at what Jeremy was talking about with feature branch workflow. And in particular, we're going to look at how it can help us work on different aspects of development at the same time, whilst keeping each strand of development separate from the others. And in so doing, this will help keep our main repository branch in a stable and working state. So I'm going to be demonstrating this using a technique called live coding. So I'm going to be sharing my screen, presenting a demonstration, and you're free to follow along with me if you wish to do so on your own machines. As Jamie said, you'll need a GitHub account and also Git already installed and available on the command line. And we're going to be providing an existing code repository which for you to use for this activity that contains some code that we're going to play with. So first question as a starter for 10, I'd just like to get an idea of who is going to be doing the activity. So if you are going to you plan to engage in the activity, that's great. Feel free to respond with a Zoom reaction of a green tick, perhaps, and that'll be great, just to get an idea of numbers, just so I can see and keep track of how things are going. Right, okay, so about 11, okay, 11 of you, okay, that sounds good. So, yes, the live coding activity we'll be doing is only really a taster. There's always more to learn. I'm going to be providing a Google Doc with links to further information and some guides for learning more if you wish to do so. Unfortunately, due to time constraints for this kind of activity, we're unlikely going to be unable to solve any in-depth technical issues you may encounter, unfortunately. But if you do run into issues, hopefully even as a demonstration, it'll give you a taste of how using branches can help when developing your code within teams, and to a great extent on your own as well. So what are we going to cover precisely in this activity? So we're first going to make a copy of an exemplar template repository on our own GitHub accounts, and then clone it on our own machines. The repository will contain a single main branch with some example Python code. For the purposes of the activity, it could be anything. We'll only be using it for illustrative purposes, a file to edit. So if you're not familiar with Python, that won't be an issue for this exercise. Then what we're going to do is we'll briefly spend some time creating a few GitHub issues, and these are going to represent some work that we'll be doing. And this is a common practice where we're basically thinking about the work that needs to be done on a code base, perhaps in response to a bug or a feature that's being requested. We make an issue on our repository that represents that unit of work, that describes the work we're going to do and why. And then once we've done that, we can work on our repository in some way, doing work that addresses or fulfills those issues. And then next, what we'll do is we'll create a new feature branch. We're going to add some commits to it, working on one of these issues, and push them to the GitHub repository. And then what we'll do is we'll show how we can create a pull request and merge the changes into the main branch. And we're going to be using a technique that Jerry mentioned, a rebase and merge strategy to do that. So we'll be looking at that in detail. And then if there's time, we'll also cover what happens if you encounter a merge conflict when merging your branch to the main branch from a feature branch, which should be a bit of fun. In particular, we'll also be looking at how we can use GitHub to resolve these types of conflict. Okay, so let's make some branches. So what I'm going to do is I'm just going to get my desktop all sorted out. So let's see, it's a lot of windows. Just need to make sure I get this readable for everybody. So let's see. Okay. Right. Okay, right, so I'm just going to share my screen again. Now, I'm conscious that I'm going to be showing an entire desktop. So please let me know if this is not readable, and I will do what I can to increase the size. Is that generally readable? So I guess the question is, would people like me to increase the text size of the terminal? Would that be of any benefit? If anyone would like me to increase the text size, please feel free to respond with a green tick, and I will increase the text size of the terminal. Okay, no problem. Right, oops. So what I always forget is that when I do that on a Mac, it always makes the window bigger. So let's see. Is that a little better? If anyone would like me to increase that any larger, please feel free to let me know. Green tick. No, okay. And similarly with this, the browser on the right-hand side of the screen, if you need that to be slightly bigger, please feel free to put a green tick, and I will do what I can to do that. Okay, right, so what I'll do So I want to make sure this is all visible to all. So I'm just going to make sure that's readable. Okay. If anyone would like me to make that any larger, please feel free to put another green tick, and I will do that. No? Okay, right. Sounds good. Let's continue. So here's a session Google Doc I'm going to add into the chat. Share my screen. I always have to bring up all the chat participant windows again. So this is going to contain some links that we'll be referring to as we go through the activity. And we're going to start with the link at the top of that document, which you will see is a link to a GitHub repository. So if you click on that, oops, let's get this right. There we go. If you click on that link here, the one at the top there, you should be taken to, oh, so someone's just mentioned quite rightly, this has not been shared. So my apologies for that. That's one thing I forgot to do. And there we go. So that should now hopefully be visible to all. Thank you very much for letting me know about that. Please, if there are any issues like that particularly, please let me know. Right, so if you go to the link at the top, you should be presented with something that looks a bit like this. And this contains some example code that we're going to play with as part of this activity. So when you are presented with this, if you click use this template and then go to create a new repository, click on that. And then what we do is we're going to name it. So I'm just going to name it the same, just for clarity for myself, but feel free to call it whatever you like. And I've noticed I've still got one of those on my account. So I'm going to call it something slightly different. Good example test, but feel free to call it whatever you like. I'm going to call it good example test, but it's up to you. Then make sure it's selected as public if you want it to be public, and then create a repository from templates. Then you should be presented with, it's rather strange because I'm pretty sure I deleted my previous run of this morning. I don't know why it's still there. Anyway, so now you should be presented with something that looks a bit like this, okay? So for those doing the activity who's managed to create their own repo from this template, if you put a green tick up for yes, or yes, you can put thumbs up if you like. I can count both. That's absolutely fine. Okay. Where is the user's template option? Okay, so what I'll do is I'll go back to the Universe HPC example here, repository, and you should see it just here. You may find if your browser is too small that it doesn't appear. I've noticed this is a rendering artifact on GitHub, which is particularly useful, particularly when demonstrating, but perhaps you've encountered that as well. If you expand the window, hopefully it should pop up and you should see it. For what it's worth, I need to be logged in. Yes, logging in is also a good idea. My apologies, I should have said that, yes, log in. And someone else said, oh, yes, that was the issue. Okay, all right. So, yes, GitHub should get their act together on an interface bit there, I think I know design. So, right, good. So what we're going to do now is we're going to open a shell. Now we have that repository created. So if you go to open a terminal or a shell or whatever it is you're using to access Git, then what we're going to do is we're going to clone that repository, and it will be the repository that you created. So it should be this one, not the Universe HPC one. So the one you've created, and you just take the URL. I'm going to do the simplest method of doing that, which is via HTTPS for now. But if you've set up SSH, feel free to do it that way instead. So if I clone that like this, and let's see who's managed to get to that stage. It's very important for us to check just to make sure this early stage, if you've managed to do that. So if you've managed to clone this to your machine, if you put a green tick into the as a reaction and a red cross if you haven't, you can always wait a little bit longer. Fortunately, we have a fair amount of time for this activity. Okay, good stuff. All right. So we're going to take a quick look at the example code here that we have. So what we can do is we can go into our repository and mine's git example, git-example-test cd to change directory into that. And I'm going to have a quick look using just an editor that I have on the command line called Nano. But feel free to access this using any editor that you please on your machine. And we can see here that we have some code. Now, the code is aims to perform some temperature conversions from Fahrenheit to either Celsius or Kelvin. The code is for illustrative purposes. And if we actually wanted to do temperature conversion, there are at least 3 other Python packages for doing this, and we'd ideally use them instead because we shouldn't reinvent the wheel when something's already been done. But for the purposes and illustrative nature of this activity, we've actually got this piece of code that basically does these calculations. Now, you'll note if you look through the code, and particularly if you're familiar with Python, there are a number of rather large issues, which is deliberate. The code is a little untidy. It's inconsistent in terms of its spacing and the commenting. It's also got some hard-coded file path at the top there, you'll notice. It's not using a library to handle the CSV data files, and there are quite a few others as well. For example, you may notice that the function names are capitalized, and perhaps we need to change these to be lowercase and use underscores between words, which is a naming style also known as snake case. Perhaps that's a coding style that we're using on our team. Also, we're missing some comments known as docstrings describing the function and the script, or the module in this case itself. So for those that haven't encountered docstrings, these essentially describe the function or the script. And they're basically special comments described as in a particular format that describe, for example, for a function, the arguments to the function and what's being returned. And it's basically enables you to document your code so others can come through and read your code and understand what the aims of the functions are. And also that helps reuse as well, because then you can see essentially what the function is supposed to do, what its inputs are, what you will be expected to return. So this is really a great way of documenting your code. It's a practice that I would recommend you get into. So there's also an incorrect function name at the bottom here called far2kels as well, which should be far2Celsius. This will cause it to fail if I do run this code, which I won't do at this point, but that will cause it to fail. So a few things to note there. The other thing to note is that on this repository, we have a single main branch. And this used to be called a master branch on older repositories, which you may have seen. And you'll notice some commits on the main branch already. One way to look at this is a single stream of developments that has happened on this main branch. We've made changes to this code base one after the other. Now, however, it might be that we may want to add a new software feature, fix a bug in our code, and this may take some time. It may be that this is going to take a few commits to complete and make it work, perhaps over a matter of hours, perhaps even maybe a day or two. And of course, as we make changes to make this feature work, the commits along the way may well break the working nature of this repository. And after that, users getting hold of our software by cloning this repo also get a version of the software that then isn't subsequently working. And this is also true for developers as well. It's hard to develop, say, a new feature for a piece of software if you don't start with software that is already working. And the problem would also become compounded if we had other developers come on board, perhaps as part of a new project that will develop the software. So we have a lot of people changing the code and making all these commits to this single branch. So what would be nice, which Jeremy has covered already, would be to have our cake and eat it, so to speak, where we can change our code using version control to check our changes, but also not interfere with the other working code on the main branch. And as we've heard from Jeremy, repository branches can give us just that. So before we go on to create some branches, what we're going to do is we're going to create some example issues on our GitHub repository. And this is going to represent some work that we're going to do throughout this session. So one thing that might be good to do is to tidy up our code. So let's add some issues to fix that script function naming bug, far2kels, changing our function name to use snake case, and also add those missing doc strings. So if you go to the new repository in GitHub in your browser, and then select issues at the top, then what we're going to do is we're going to create some new issues. So once you've done that, you can select new issue. And then in the title, I'm just going to add something which says something like functions should use snake case naming style. So I'm keeping this a very specific issue in this case. So in the summary, I'm going to add something like the following, but this is just for completeness. Feel free not to do this if you don't want to type all of this in. So naming a function currently is using capitalization. So I'm describing what the issue is, and also what I believe to be the resolution in this case, which is to follow snake case naming instead. So as a team, perhaps we've been working on this code and we've elected to follow a coding style which uses snake case naming. And this particular piece of code doesn't actually have that, isn't consistent with that coding style. So for the purposes of activity, we can also assign, what we'll do is we'll assign this to ourselves. So we'll be actually working on this. And then once we've done that, we can submit the issue like this. Now, we should find we have an issue that looks like this. And what we're also going to do is add 2 more issues. So if you look in the Google Doc, you will notice there are some titles for the issues to put in. So these 2 here are the ones we have yet to put in. So what we'll do is create 2 new issues. So again, we'll just click New Issue, and you can copy and paste each of those into the issue. Don't worry about putting in any description into the issue, more details, unless you really want to. Actually, copy and paste it correctly. Perhaps that would help. There we go. So I'll give you some time to do that as well as I'm messing around with copying and pasting. So I'm going to assign myself to that one too. So I'm going to add the doc strings to the function and the module. Submit that as an issue. Then the final one, script fails with undefined function name error. I'm going to assign myself again and submit that issue. And what we'll do is we'll refer back to these later as we address these units of work. So let's see, a quick check then. So who's managed to create 3 issues on their repository? Feel free to let me know by having a green tick there. If not, a red cross if you perhaps would like some more time. And I see there's been some questions in the chat, and my thanks to Jeremy there to addressing those questions, giving some answers. Okay, so we'll just wait another few moments. So I see one person hasn't yet been able to do that. So if you need any help with that, please let me know. Feel free to put that into the chat, or I'll wait until you've removed your green cross and replaced it with a tick, and then we'll continue. Right. Okay. So what we're going to do is we'll move on. I see this one person is still apparently putting in some details for the issues, but feel free to continue in the background. Brilliant. Okay, you've just acknowledged that you've been able to do that. Thank you so much. That's very helpful. Right. Okay. So what we'll do is we'll now continue. So the next thing we're going to do is we're going to start working on an issue, on our first issue, and we'll start by working on the missing doc string issue. So if we go back to our issues by clicking here, missing doc strings, which is issue 2, that's what we're going to be working on. And we've assigned it to ourselves, so others in our team would know that that's what we're doing. So what we're going to do is we're going to exit our editor in this case with Nano, which is Control-X. Then what I'm going to do is we're now going to create our feature branch. Also known in some places I've noted as topic branches as well, and we're going to work on our docstring fix or using that branch on that branch. So on the command line, what we'll do is we'll just see where we are. So I usually, before I do anything, I always do git status. It just gives a quick kind of bird's eye view of what's happening with our repository. We don't have any changes that we've made. We're on the branch main that you'll see there. But what we're going to do now is we're going to see what branches we have, so we can do a git branch. That tells us there's only one branch that's currently on our repository, which is called main. If we do git log, we can also see that we only have one initial commit so far. Now, in order to get started on our docstring work, let's tell Git to create a new branch by using git branch again. But this time what we're going to do is we're going to give it an argument. Now, when we name the branch, it's considered good practice to include some more information that describes the branch and the work that we're going to do. And it's up to you within your team and your colleagues how you choose to do this. And I've seen many different approaches, but one way I'm going to do it is by basically stating the issue that I'm going to be working on and a very quick summary of what it is that I'm fixing. So at a very sort of quick bird's eye view glance, someone seeing this branch will be able to ascertain this is related to issue 2, and that's the work I'm doing with, with fixing some missing doc strings. Okay, so we've created the branch there, but now importantly, if we do git status, we're still on branch main, and it is a common mistake, and I've done this so many times, where I've created branches and not actually switched to the branch where I'm doing the work. So what I need to do now is I need to check out that branch. So git checkout issue -2 missing doc strings, referring to branch I just created. Someone's put into the chat question, if you fix an issue, does the numbering of the issues change? No, the numbers of the issues will never change even when they're closed. So when you've done work on an issue, you perhaps put some comments into your issue, you've done some fix in your code base related to the issue, and then effectively the issue is done and you've finished it, you've then closed the issue. If you do that, the issue will never change. It'll always be issue 2. So it's to be consistent, which is great because it means that what GitHub is really good at doing is integrating a lot of all of its features together. So for example, when we do commits, we can reference an issue number directly in our commit message, and that will always refer to that specific issue, and that number won't change. So it's really good to keep a fixed record of what's actually happened. Okay, so what we're going to do is we're going to check out that branch. Right, so now what we need to do is we need to see, if we do git branch again, we should see that we now have 2 branches. There's an asterisk, and also on my machine, at least, it's highlighted in green which branch I'm on. So that's another way for us to check. And again, if we do git status, another very good thing to do is it tells us we're on branch issue 2 missing doc strings. Okay. So this is a really good habit to get into. I use git status before I do pretty much anything. It helps to clarify what branch you're on, any outstanding changes you may have forgotten about, which is very useful. So now one thing that's important to realize is that the contents of the new branch are at the state at which we created the branch. So going back to what Jeremy was talking about with what we're doing when creating branches, we're now branching off from our main branch, and we had 1 commit on the main branch. And that's effectively where we are now. So if we do git log, we should see there's only still that initial commit. So we've inherited the state of the repository at the point we did the creation of that branch. So that's where we effectively are. So any commits we do now will be on our new feature branch, and will depart from this commit from the main branch. And also will be separate from any other commits that occur on the main branch as well, as Jeremy was talking about earlier. So now we're on our feature branch, we can make some changes to fix this issue. So what we'll do is we'll open up our climate analysis.py file, climate_analysis.py. So what I'm going to do is I'm going to add the following to the far2Kelvin function. So what I'll do is I'll copy and paste this into the chat, so you can copy this yourself if you wish to type it out, but feel free to copy and paste this from the chat instead if you wish. So yes, one thing we didn't have was a doc string describing this function. So I'm just going to quickly put this in. So I've basically got converts Fahrenheit to Kelvin. The arguments, as very similar to the far2Celsius function, is Fahrenheit far, which is a float of type float, and it's a temperature in Fahrenheit, and it returns a float, which is a temperature in Kelvin. And someone, Matt, thank you, Matt. That's a very good suggestion. What you can do is you can use git checkout -b feature/branch name, and it will create a new branch named feature/branch name, and then it'll automatically switch to it, which can avoid the issue of creating the branch and then forgetting to actually switch to it. So that's a really good practice to use if that's something that works for you. So now we've done that, we've got this. We can now save that file. So in Nano, I use Control-O, press return, and that will save the contents of the file. So quick question, just to see who's with me, who's managed to add this doc string to the file and then saved their file. So a green tick there. It doesn't matter particularly what you put into your doc string. Okay, so I can see almost everybody's managed to do that. Okay. So I'll wait just a moment longer. Okay, so I can see others have just finished up there. Again, it doesn't really particularly matter. I'm just following the convention there of what I've already done here. The other thing that's interesting about doc strings is there are many different forms of doc strings, different types, different formats of them that you can elect to use within your project. But the key is to go for one that works for your team and you use consistently across your code base. Consistency really is key. Okay, so not sure how, okay, all right, so someone's just directed a message at me. I'm not sure how to open the file. Okay, so sorry, I'm just dealing with one issue there. You can, what you can do if you're struggling to open the file, if you're on Windows, you can use your file browser to navigate to the repository and then open the repository in the file browser, the directory that contains it, Git example or Git example test. And then what you can do is you can right-click on climateanalysis.py and then open in an editor. That could be Notepad, for example. If you're on Linux, you should be able to use Nano as I have. Right, so whilst that's ongoing in the background, I will continue for now. But once we've done this, we've made this change, we can commit the change to the repository on our new branch. So if we do git add climate, so we're now using Git very much as we would normally if we were just using one branch. We're just adding our commit, so we're going to add commit now. Now, importantly, what I'm going to do is I'm going to reference the issue that I mentioned you can do before in the commit message. So there are a number of ways to do this. I'm going to go, and I do apologize, my bar is in the way. There we go. So add missing doc string. So I put #2. The hash represents a reference to an issue. 2 is the issue number, and add missing doc string. So there we go. So I kept it short and sweet. I'll actually add to a function just to be specific. There we go. So we've committed that. Now if we do a git log, we can see that on this branch, we have our initial commit we've inherited from main, but we also have this other commit message, which indicates that we've done some commits related to issue 2. And now what we're going to do is we're going to add a module doc string to this file as well. So we now go back into our climateanalysis.py file. I'm going to add something at the top. It doesn't really matter what it is, but I'm just going to add something which looks like this, which is a very short comment explaining what the module is and what it actually does. So anyone, including myself, further down the line, looks at this file, I'll be reminded what it is trying to do. So a quick question for all of you, not just those doing the activity. Who's ever written some code and then come back to it and gone, what is this code? What was I trying to do? Or being confused about that code in some way? I'm going to raise my hand quite heavily there. Quite often I've written code in the past where I've come back 6 months later and it's been a little confusing either to understand it. And in some cases, when it's been a lot longer than that, what even I was trying to do. So see if some of you have experienced that. Don't be alarmed, it's quite normal. So again, you know, we're documenting this code, but we're not just documenting it for other people, we're also documenting it for ourselves. And a really good sort of mind space to get into when you approach writing code is always to assume you're writing the code for someone else to read and also for someone else to change. And that someone else can be you 6 months or a year down the line coming back to this. And to be honest, you know, once you've got into the habit of commenting your code regularly, particularly with things like doc strings, it makes coming back to it and understanding what's going on a great deal easier. And also I find the process of actually writing doc strings is really useful because it can help to clarify your own thinking about what the functions are actually trying to do. And sometimes you can come up with better ways of actually doing that whilst you're describing or writing the doc string. Right, so now we've done that. So quick question, who's edited the file, made the changes and committed them? So what we'll do is I'll save my file. I'm going to add this. So I'm skipping ahead, my apologies. So what I'll do is we'll now all add these changes, we'll save our file and make, what commit the changes. Again, we're working on issue 2, but now we're adding a missing module dog string. Like this. And if we do git log, as before, we now have another commit that has appeared on our git log. Okay, right. So quick question, who's edited the file and made the changes and committed them? Who's done that now twice? We should have done that twice. Yep, I can see you've all done that. You're really quick to respond, so I can see that you're chomping at the bit to continue. So let's try and push on. So now let's push these changes to GitHub. Now, since this is a new branch, we need to tell GitHub where to push the new branch commits by naming the branch on our remote repository also. So if we just type git push, that's not going to work. We get a suggestion telling us so, that we need to make sure that we're telling it where we're uploading it to. So what we can do is we can use git push and set upstream. So we're going to set the upstream, so origin, which refers to the remote repository that we cloned from in this case. And we're going to call the branch the same thing that we have locally, like this. And if you do that, then you should find that we've created a new branch. And you will notice that here it is quite nicely suggesting that indeed what we could do is we can create a pull request from this if we wish to do so. So we've essentially fixed this issue now. So next we need to somehow merge these changes on our feature branch with the main branch. And we'll do that now by using a pull request. So now before this, particularly if it was code particularly if it was code I was changing, I would normally have tested these changes and ensured the code is working properly. To save time, we haven't done that here, but that's definitely something worth noting. Before pushing any changes, always a good idea to test your code first. If you have any unit tests, run those too to check that your code hasn't broken, you haven't broken anything in your code as you've been making changes. And also, particularly if this was a change implementing a new feature, I consider writing a new unit test, if that made sense to do so, to test the feature, or perhaps indeed more than one unit test, depending on what it is I needed to test on the code to make sure that it was working correctly. So those of you familiar with unit tests, that's a way of sort of filtering this into your workflow. So one thing we did at the previous Research Software Camp session on code review, we used pull request as a mechanism to review code changes across the team. So I'd just like to get an idea of who was at the previous session. So if you're at the previous Byte-Sized RSE session, where we looked at code review, feel free to let me know with a green tick. Okay, so a few of you. Okay. So we're going to be using a pull request here too, but if you weren't present at the previous one, so a pull request is a way to propose changes on a particular Git branch and request they be merged with another branch. In this case, we'd want to do this with our main branch. Now, they're really useful as a tool in Team since they provide a way to check the changes before doing a merge. They also allow you to see the changes to files across all the commits in the branch and look at how these commits will change the code base. And perhaps by doing so, that will tell you, that there are some people that need to be informed of some of these things. And you can do that within the context of a pull request. And then you can assign a number of reviewers to review the pull request, and they can submit a review on their thoughts as to whether to accept the pull request or make changes and so on. So as you're making changes, you can bring in reviewers who may be affected by the changes you're making, and they can have a look at your pull request and the changes you're proposing, and then they can comment on this pull request. And then once you've reached consensus on the state of this pull request and whether it's ready, you can then continue with a merge. Okay, so we could create the pull request on the command line. Indeed, there are ways of doing that. But what we're going to do is we're going to use the GitHub interface to do it, which, frankly, I think, in my experience at least, is much clearer, and it also gives you a far better top-down view of what's actually going on with a pull request. So let's go back to our repository on GitHub. Now, if we go to the root of our repository, we click on our repository roots, we should find that we see something that looks a bit like this. You may see a message about protecting the main branch. This is something we perhaps can come on to a bit later. And if we select the drop down where it says main, we should see we have our other branch here, which is now popped up. Now, this is our branch that's separate from our main branch. And if we select that, we can then see the state of the repository within this branch. So you'll note that in our main branch here, you'll notice we're still on our main commit, which is what we would expect. And if we go to our new branch, we should find we have a different state of affairs. We can see that if we go to our list of commits, you can go to commits here on this branch, you will see that we have our 2 additional commits. Now this is tallying with what our picture of what had happened on the command line, but we're seeing this now in GitHub. So I'm going to go back to the main repository root. And then what I'm going to do is, let's see, we're going to create our pull request. Now I'm going to do this by going to compare a pull request, but you could also go to the pull request tab here, then create it from there. But just for convenience, I'm going to click on here, compare and pull request. Now, it shows us the interface for creating our pull request. Now, importantly at the top, it shows us which branch will be merged with which branch. We can see here that the target branch is going to be main, that's the base branch, and then it's going to be the changes are going to come from our issue to mission docstrings branch, which is what we want. And it's telling us quite handily that we're able to do these merges without any conflicts, which is really useful thing to know. You may rightly ask, what do I do if there are conflicts? And that's a very good question. We're going to come to that bit later. So below this also shows us the commits associated with this branch. And and also shows us the sum of all the changes across all of the files, which in this case is just a single file. We can see here we've put in our docstrings there for our function and our module, representing the 2 separate commits. So this is showing us a kind of a snapshot of the changes that we've made across this repository. So that's useful to know. Okay, right. So we're going to rename the PR a little bit to reference issue 2 a little more directly, with a little more specificity. You don't have to do this, but it's something I tend to do. So I'm going to say it fixes #2 missing doc strings. So I'm sort of adopting the same format there as I did for my commit message. Now I could also add in some more information if I wanted to, and I could also, over here, you'll notice I can assign some reviewers to the pull request if I wish to do so. But for simplicity, we're going to leave those for now. But we can assign the PR to ourselves, and that's a good idea. It's always a good idea to assign responsibility where it makes sense to do so. In this case, I'm assigning myself as the person responsible for it. So when there's like, I don't know, maybe 5, perhaps 6 pull requests on a repository, people can see where they're originating from, but also the responsibility of who is managing those pull requests. So if we'd assigned any reviewers, we'd now wait for their reviews of this pull request, and we could assume we'd just done that and the PR is good. And again, this is a major strength of using PRs, and I thoroughly recommend it. By PRs and having reviews of PRs, it's not just a number of people making changes in isolation. In collaborations around software, it's so important to increase the flow of information between people making changes, particularly in cases where there are new potential issues that could be introduced as a result of these changes. And PRs kind of give us that level of discipline. It's an opportunity really to make sure the changes we're making are well considered across the team. And this becomes part of the overall cycle of development. We write code, we create it as part of pull requests, we can have it reviewed, it gets merged, but also we can also help with reviewing others' pull requests as well. And this is a great way to increase the knowledge of the code base as development continues. And as the code base potentially expands and becomes more complicated, that can become more and more important. Now, even though, let's just check. And what we'll do now is we're going to create our pull request. So just a quick check, let's see who's managed to create their pull request. So green tick if you've got to the state where you've been able to do that. And I appreciate there was a few complex steps we took there. Okay, good. Right. So now we get a new screen describing the PR itself. And so yes, let's see, we could be doing the assigning of reviews at this point. And it also tells us we can merge this branch automatically as well. So if we scroll down here, it says the branch has no conflicts with the base branch. Now, something that's interesting here is that we can see that we have the list of commits so far on this PR. Interestingly, we've created this PR to do a merge, but we could also continue developing our code on this branch indefinitely if we wanted. Whilst this pull request is open, we could make and push new commits to this branch, which would show up here, and then we could do a merge at a future date. And this may be particularly useful if we need to have a longer discussion about the pull request as it is developing. Perhaps it impacts a number of other factors within our code base, and we need to discuss this before the pull request can be perfected. And we could do that within comments within the pull request if we wish to do so. And then at a future date, when we're ready, we could merge that pull request. Now, it also raises the question of how long PRs should be open, or even branches in general for that matter. To some degree, it depends on the nature of the changes being made, I think. But branches in Git are designed and should be, wherever possible, short-lived. So the longer a branch is open, the more potential changes could be made to the main branch and elsewhere in the code base. So when it becomes time to merge the branch at a later date, we may get a lot of conflicts we need to manage. So generally, it's a good idea to keep your branches open for a short period of time, perhaps a day, a few days, maximum really, before creating your PR, doing a merge if you can. Note that we can also see this PR as well as any others by going to the pull requests tab. So we get to see a picture of all of our pull requests that are existing on this repository. So that can be useful to know. So what we're going to do now is we're going to rebase and merge this into our main branch. Now, if you scroll down, you'll notice there's a subtle drop down on the merge pull request button. And one other option we have is how, with this pull request, is how to do that merge. You may remember Jeremy talking about rebase and merge as opposed to just doing a merge commit. And this can lead to a cleaner repository history. So, for example, if we did a normal merge here, we'd end up with our 2 commits and a merge commit. But if we want to do a rebase and then a merge, our 2 commits are essentially just added to the top of the main branch. So let's do that. We'll select the drop down here, go to rebase and merge. Note that if there had been a conflict with any commits on the main branch, we very likely wouldn't have been able to merge using this method, which in itself is a good question. So even if we'd done a straight commit, what would happen if there was a conflict? And if there's time, we'll look at that later. Right, and a question came up earlier, I think, about the disadvantages of using rebasing. So you can do rebasing when you're doing merges of pull requests, but you can also do rebasing in general with branches on the command line. And I think that's worth a word of warning. So when you're using rebasing on the command line with branches that you're working on, be sure that you do know you've had some practice in doing this, because rebasing in this way can effectively rewrite the repository's history, because that's what you're doing when you're doing a rebase. And therefore, with rebasing, there is a golden rule, which is something that is strongly recommended you follow. And I've put a link to this in the session doc notes. Basically, it states that whenever you should only do rebases with a local branch and never a public shared branch you suspect is being used by others. So when rebasing, since you're writing the history of commits, if someone else has the repository on their own machine and has worked on a particular branch that has become public, and you rebase on that branch, the history will have changed and they can run into difficulties due to this rewritten history. So it becomes difficult for the Git client to reconcile the history that you have on your local machine with this new revised history that exists in the repository. So it can get quite messy. So if you are in doubt, just feel free to do a standard merge. We'll talk with your colleagues about when and where you want to do your merging. Okay, right. So if you then, let's go ahead and rebase and merge. So if you now click on that. So now what we could do is we could add more information here if needed, but we'll do the confirm, rebase, and merge. So let's just do that. And let's have a look. So it says the pull request is successfully merged and closed. They're all set. And it also tells us that we can delete the branch. Okay, so who has successfully managed to do that merge with the pull request? Put a green tick into as a reaction or a red cross if you haven't quite got there. Okay, so it looks like you've managed to get to that stage. Okay, right. So yes, we've said that branches in Git should be short-lived wherever possible, and keeping branches hanging around may cause confusion. So let's delete that branch now. We have the option to do that here. Okay, so let's just delete the branch. We don't need it anymore. The work has been done, so we select that. Now, if we go back to our repository root, and then we have a look at the commits on the main branch, we're now on the main branch, we should see that we have our initial commit followed by those two added commits that we had on our feature branch. So that's what we would expect to see. So we've had these added. So this is looking good. Now, the other thing is, remember those commit messages with the issue numbers that we were adding as we were writing them? If we go to our issues now, what we can do is we can see each of our issues, but also if we have a look on, for example, our docstrings one, you will notice that it's been able to pick up that we've been working on this issue with our commits and also added these commits to our issue. So we see the history of work that's actually happened as part of this unit of work. So why are there two sets of commits when we only made one? It's because when we first did this, we were making two commits to the branch, which represent these two. And then when we did the merge, these were then put on top. So that's why you're seeing this reference twice in the history. Okay, so what are the benefits that we've seen so far by using this kind of method? So by using different feature branches as opposed to just committing directly to the main branch, we've isolated the churn of developing a feature from the main branch. So this is really a very key benefit. It allows us to maintain a working main branch. It also gives us the opportunity to abandon a branch entirely if we wanted, with no need to manually change things back. In such a case, all we need to do is delete the branch. So this could come up if we were developing a new feature. We're not quite sure how we want to do that. It's going to take some while for us to explore that. We could create a feature branch to implement this feature. We could then explore by making changes to our repository to implement that feature. And perhaps, we get to a point where we think, no, this approach isn't working. What we need to do is we need to do something else. And we could just then abandon the branch, delete it, and go back to our main branch, and then start again if we wish to do that. The other benefit is in the other direction. We're also effectively isolated from the changes being made on other feature branches. So when a number of changes are being made on these branches, we hopefully only have to worry about our own changes, unless our colleagues tell us, of course, perhaps in a pull request, about things that may impact the code base as a whole. And it also gives us a process that helps maintain a working version on our main branch for our users, which may very well include ourselves. And it gives us a mechanism via pull requests to have others review our code before changes are introduced into the code base. So there's a lot of advantages of using this approach. And what we've shown is one way to use feature branch workflow, where we've used feature branches directly off the main branch and then merging to main. We've chosen it this way for the training, so it's more straightforward to teach in a practical activity, but there are other ways to do this. So another way is to use a long-lived branch off of the main branch, called usually something like dev or develop. And this is one I've been very familiar with and using this a lot recently. And this dev branch would represent a general branch of development. And using this approach, feature branches are created off of the dev branch instead, and then merged back to the dev branch, okay? So you don't create your feature branches directly off main. What you do is you check out the dev branch, create your feature branches from that point, and then once you're finished with your feature branches, then merge back to the dev branch. And then when a release of the software is due or at an appropriate point in the future, the dev branch is then merged with the main branch. And this gives development a greater distance, even greater distance from the main branch, which could be a good thing. And it means you can merge and test all changes together on that branch before you merge with the main branch to ensure it all works together. But it also means when it comes to doing a merge, it can be more difficult since the dev branch could have built up a considerable number of changes that need to be merged. That's something to be conscious of. But in either case, the key is to make sure that the code is tested and checked with the right people in your team before you actually do that merge to main. So I think one thing we could do very quickly is we could go on to dealing with a branch merge conflict. And I think we could probably do that relatively quickly. So that's something we could do now. Okay, so let's have a look at what people would like to do, given we have 8 minutes left. So a question I'm going to ask is, who would like to go on to dealing with branch merge conflicts? Green tick for yes. If you'd prefer to go on to a Q&A session for the last 7 minutes, then show a red tick. We'll let democracy decide. I see there have been a lot of questions in the chat as well in the meantime, so hopefully that's been enough to answer those questions. Okay, so I think people want to go on to doing merge conflicts, so let's do that. So we still have two other issues that we can look at, and these are interesting. So both of them require changes that cause a conflict and merging, and let's look at these now. So first, what we'll do is we're going to go to main, our main branch, and then we'll pull the repository changes on the main branch to a local repository. Since what we've been doing so far is managing our pull request using GitHub, and if we're going to do some work, what we should be doing, excuse me, is pulling any changes down from the remote repository. So we're going to do git checkout main, so make sure we're on our main branch, and then do a git pull, and that will pull down all of the changes that we've seen now that have come onto the main branch, or the changes that we've made to climateanalysis.py. If we do git log again, we should see we have these 3 issues. So now we know that our repository is in a mirrored state with what's on the remote repository. So what we're going to do is we're going to create excuse me, a new branch called issue1 use snake case. And what I'm going to do is I'm going to check out that branch as well, like this. So once you've got to that point, for those that have wished to follow along at this stage, please feel free to put up a green tick. Okay, right. So what I'll do is moving quickly on. What we can do is we can look at our climateanalysis.py file. And what we're going to do is we're going to change, you may recall that we need to change this to snake case. So what I'm going to do is I'm going to do exactly that. So far to Celsius, so I've basic lowercase and underscores separating the words. Do that for all of these. To Kelvin, and we also need to do that importantly in the function calls as well. There's a function call I always forget to change, which is this one, to Celsius. So essentially what this is doing in a rather very naive way is using the function that already exists to convert it to Celsius, and then effectively adding 273.15 to get it to Kelvin. Okay, so there's that, but we also need to change the function calls as well. So we do, Celsius, then bar to Kelvin, like that. Now, once we've done that, we've made those changes, feel free to put a green tick, and then I will continue. So if you've managed to make those changes, okay, righto. So what we'll do is we'll now commit those changes. Just as we have before, git add climateanalysis.py, and we're going to commit the changes. Short and sweet, use snake case. Now we can push this as before to our remote repository, but we also, again, have to remember that we need to ensure that we name the branch of where we're pushing it to, like that, as we had before with our previous push, like that. Now, at this point, we could follow this advice and merge this branch's work into the main branch, and it'd be very neat and tidy, but life's already like that. And what happens when someone else commits their changes in some way to the main branch? Where does that leave us when it comes to merge? Well, what we'll do is we'll now find out. You may recall we created an issue for creating the function call to far to Celsius. There it is, that one there. The call referenced the function incorrectly. The function name was essentially wrong. So let's assume that a colleague has made these changes and updated the main branch. Hopefully they've done this on the feature branch and merged it, but maybe not. Now, we're going to pretend, for the sake of argument, that we're our colleague, and we'll actually do what we think that they've done. Okay, so we're colleague A or something. And what we're going to do is we're going to go back to our main branch. We're going to just do a quick git status. Okay, that looks good. Now, this branch is completely unaware of the commits in our new feature branch and is at the state of the repository when we merged our previous work from our other pull request. So what we're going to do now is we're going to make the fix. Now, we could and should create a feature branch here ordinarily to make and commit the change, then merge with the main branch. But for the sake of time, what we'll do is we'll just commit directly to the main branch and assume they did it this way. Okay, our colleagues. So we're going to aim to change our file. And where it says far to cells at the bottom, we're going to put in what we believe to be the correct function name, which is far to Celsius, which at least in our view of the world is the case. Now we've done that. Let's do a git status. Okay, so yes, that looks good. Analysis.py, and then git commits 3. So okay, fix incorrect function call, like that. So again, we're just committing our change. Okay, so this is our view of the universe where we are in main at present. Okay, and now if we do git push, we can see that we do now, we have this extra commit on main. Now let's see what happens when we try and create a pull request on our feature branch as before and try and merge it. So let's go to our repository root. Do it a slightly different way. Why not? So let's go to pull requests and select new pull request. We're doing this a slightly different way. So what we need to do is we need to set this up. So what we do is we select from here the branch that we wish to source the changes, which in this case is issue 1, use snake case. We select on the compare main button there, change that to compare and our new branch. Now it's handy that it does this. It's comparing the source and destination branches and determine that there's a conflict. So since there are different edits on the same line for commits in the main and feature branch, we've actually encountered this. But what we'll do is we'll go ahead and create the PR anyway. And just go straight to pull request, create the PR. And what we can do now is we can select to resolve the conflicts that exist in this file. Now you'll notice that it says this here, and I'll very quickly make these changes. So here it tells us that these are the changes that we need to sort out, and I need to remove the bits to make it the view that I know to be correct. Once I've done that, I can go to mark as resolved and commit the merge. So I've resolved and fixed those issues. So yes, I'm cautious we're running out of time. So yes, I think what we'll do is we'll wrap up now and give an opportunity for people to leave. So what I'll do is I will, let's see. Let's get hold of, so apologies that we ran out of time just towards the end there. So what I'm going to do is I'm going to put a link to the survey into the chat. And if you have a few minutes, it would be really great if you could fill that in for us. Okay. Right. So thank you for following me along with the activity there. Again, apologies we ran out of time near the end, but I do hope that was a useful exercise if you were engaged or following along for that. Right. Jeremy, over to you. Would you like to wrap up, or I'm happy to do it?
Yeah, okay, thank you, Steve. Yeah, I think just to say thank you very much to everybody for joining, and thanks to the SSI team, Dennis and Gina for hosting. And yeah, we're certainly, I'm happy to stick around as well for a little bit, so we can certainly answer any questions or go into anything in more detail that you might like after the session. But otherwise, I think that's all for me. And do provide feedback if you can, because obviously we really appreciate that, and it's very useful to help us with future sessions. But otherwise, thank you all for participating. Thanks for sharing all your thoughts in the interactive parts of the session. And yeah, do look out for more of these sessions that I guess we will hopefully be able to do in the coming months. Either, probably independently of the research software camps, but I'm sure there'll be also more research software camps as well. So thank you all very much.